the Davies Use Case webinar being presented by UT Southwestern Medical Center on data-driven decision-making. This is a Davies Award-winning use case for the value of health IT. My name is Arnold Simmons. I'm the Manager of Quality and Patient Safety, and it's my pleasure to moderate this presentation. Is promoting the use of health IT to improve the quality of healthcare delivery. HIMSS integration of clinical decision support and best practice guidance. Analyze progress and IT-enabled patient safety tools for all healthcare organizations, clinicians, patients as vehicles for improving patient outcomes. The HIMSS Nicholas E. Davies Award of Excellence is the pinnacle of the HIMSS Value Recognition Program. The Davies outstanding achievement of organizations from around the world who've utilized health information technology to improve patient outcomes and value. The Davies Award-winning use cases have been peer-reviewed to validate sustainable, improved patient and business outcomes resulting from health IT-enabled care delivery. So it's my pleasure to welcome our speakers for today's call, and I'll turn it over to Dr. Willard to introduce them.
Thank you. My name is Dwayne Willett. I'm the CMIO at UT Southwestern Health Center in Dallas.
Oh, thank you.
Mm-hmm. Yes.
Data sources, we got multiple answers.
Okay. Ambulatory Chief Medical Officer and a practicing interventional radiologist. With that, we'll turn this over to Ki Lai.
I remember an executive used to say to me, "Hey, Ki, why is it that when I ask 3 people what our length of stay is, and I got 4 different answers?" And that was actually our situation back then. So we look into the situation and identify a few contributing factors. First, we had very inconsistent business rules for the same measures. On top of that, the business rules for some measures were simply just too complicated. Secondly, different analysts were running one-off queries while making their own assumptions of the business rules. Some measures require joining data from multiple sources, which is not a trivial task and can often lead to different numbers. Sometimes the data is there, but we just use it incorrectly because there was a lack of communication or documentation about the data. Finally, we recognized that some of our dashboards were too difficult to use. All these factors contributed to us getting different answers for the same question. This then lead to waste because we now had to pull together our best analysts and have them spend time reconciling the differences. So what did we do about it? We took a holistic approach and re-architected our data warehouse. So we first focused on our governing function. We created an executive steering committee which helped us set the priorities for our data warehouse initiative. Based on the priorities, we formed individual business rules work group, and the work groups determine what data sources should be used and define the business rules of the measures. We also partition our data warehouse into 2 environments. We call them pre-approved and approved environments. Measures that require extra scrutiny are actually loaded into the pre-approved environment first. Once the stakeholders have the chance to review and approve the numbers, with a push of a button, we copy the data to the approved environment for consumption. We create a star schema data model using the Kimball methodology to address the challenge of having many one-off queries. The data model contains facts and dimension that has been defined and validated. And from a compliance perspective, we implemented role-based security on the data warehouse. We also created a unified architecture. So regardless of the database technology of the source system, the data from all systems are stored in a uniform technology stack so that anyone who knows the SQL programming language can query the data. Data that flows into the data warehouse, we knew that we had to invest in automating data quality checks, and that's what we did. And to minimize incorrect use of data, we created an online data dictionary that tracks business definitions and technical documentations of the measures in the data warehouse. As for improving, we implemented Microsoft Power BI, making it an enterprise business intelligence tool, particularly to support self-service analytics. We also created the capability to take the measures created in the data warehouse and write them back into Epic. With this write-back capability, our providers are able to access measures produced by the data warehouse without having to navigate out of Epic hyperspace. Architecture framework in place, we were able to make the data warehouse a single source of truth, producing consistent and reliable measures based on the business definitions that have been defined. So, architecture obviously did not happen overnight. Our data warehouse initiative started 14 years ago. Overall, it has been a journey of continuous improvement. We actually started with loading just professional billing data from Epic, and then later on broadened the scope to various modules within Epic. We then also brought in different data sources. To date, the data warehouse contains data from 33 different source systems. All the raw data from this system first arrive in the data lake. From there, we apply data quality checks and then execute our rules engine to map and process the data. The processed or the curated data is then saved in the data model. On top of multi-dimensional cubes to optimize performance. The major components of the data warehouse available for query. The data lake that I talked about, the data model, the cubes are all accessible depending on your level of access. To access the data, advanced users can use any analytics tool to query the data warehouse and perform descriptive, predictive, or prescriptive analysis. Another way for users to get to the data in the data warehouse is through standard reports. We have published a suite of standard reports on our portal. We also make the data available via self-service dashboard with advanced visualization using Microsoft Power BI. Finally, as I mentioned before, we push the measures generated by the data warehouse back into Epic so that they are accessible within Epic hyperspace. Here's an example of our data model. Let's start with professional charges. Every single transaction in professional billing is stored in a table, which is commonly known as a fact table in data modeling. Analysts are familiar with analyzing professional charges by provider, date, department, and so on and so forth. So we have dimensions for provider, date, and department, and others. Let's say we have another fact table, and this one is for grant funding. The same provider dimension used by professional charges is linked to the grant funding fact. Furthermore, the dimension can again be used to link to, say, another fact table, in this case, patient quality measure. So just with this relationship that you're looking at here, one could actually look at a provider's grant activities, cross-reference them with her clinical billing activities, and see how all this affects her patient's quality measures. Overall, there are about 500 such fact tables in the data warehouse, and we can analyze them by approximately 20 different conform dimensions. Return on investment. Since it is not straightforward to measure return on investment for making the data warehouse a source of truth, we've opted to just focus on the self-service dashboards offered by the data warehouse. In August, the self-service dashboards were accessed about 8,800 times. Imagine for a moment that these self-service dashboards do not exist. What that means is that our users will be forced to submit a request for a report to our reporting team. And let's say on average it takes a reporting analyst about 20 minutes to fulfill a reporting request. And that's pretty conservative. So it would have taken close to 3,000 hours to fulfill all the reporting requests for that month. But because we've made self-service dashboards available to the users, they were able to get their answers right away without needing any help from the reporting analyst. And with that, we're looking at a savings of $160,000 a month, which is close to $2 million a year. Next, I'll hand the time over to Deepa, who will talk about analytics generated from the data warehouse.
I have to do the first slide again. Okay. As part of UT Southwestern's quality initiative, we implemented patient registries and clinical quality measures for specialties across the health system. Through a coordinated efforts, the health system's quality, operations, information technology, and analytics teams worked together using an agile framework to develop 163 quality measures associated with 43 specialty-based patient registries. The measures included process, clinical outcome measures, included patient-reported outcomes. I will walk you through how we implemented the reporting and analytics for this project. Here's an example of the rheumatoid arthritis registry. DMARDs that are disease-modifying anti-rheumatic drugs are the best practice guidelines for the treatment of these patients. At the start of this project, we wanted to measure our compliance to prescribing DMARDs for rheumatoid arthritis patients. Our baseline data revealed that our rate was at 93, was higher than the national benchmark at 93%. Next, we wanted to measure how our patients were reacting to this medication. We started measuring CDI, which is the Clinical Disease Activity Index, that includes a combination of the patient-reported outcome and a provider's assessment of the patient's condition to stratify the risk for these patients. Using, in our initial data, what we found was that our compliance to CDI was really low. By continuous feedback to the providers and performance improvement methodology, we were able to increase our process measure from 42.7% to 80.9%. Using this data, we were able to stratify of risk and tailor their interventions. Through this process, we are seeing that we are able to shift the percentage of patients from the higher disease to a lower disease activity. Here's an example of a Power BI dashboard that is used to track these specialty measures over time. Using the filters on the left, the user can select the desired specialty registry and the quality measures to see how these measures are performing over time. The example above is filtered to the rheumatoid arthritis registry in rheumatology. Has access to their quality measure performance data using dashboards in Epic. Provider-level dashboards delivered to Epic are consistent and have clearly defined definitions and are powered by the data warehouse. Epic dashboards have a combination of real-time data from Epic and data from the data warehouse. The dashboard on the right shows the provider's performance and compares that to the department's performance. There's an ability to drill down to individual patients to identify specific patients for whom care gaps need to be closed. This is a quality leadership dashboard that allows them to identify their top performers and identify providers with opportunities for improvement. This dashboard facilitates targeted performance feedback and allows us to coordinate our performance improvement efforts. Here's another view on the same dashboard. The chart shows that we have not only increased measure performance, but we've actually reduced variation in performance rates among providers over time. Let me talk a little bit about the quality measures framework that was used for this project. We identified the population of patients with a specific condition or criteria, next, the clinical quality measures that were associated with this population, and then we flagged the measure, denominator, numerator, and exclusion criteria for these patients based on the quality measure specifications. We used a single framework for handling quality measures across all the registries. We used the exact same framework for handling quality measures received from external sources. So for this large organization-wide project, we brought in facts about a patient's care into the data warehouse. Quality measures, as you know, are fairly complex. Each quality measure could have inputs from several different areas of a patient's electronic health record. Additionally, patient-provider attribution is a key aspect that can impact quality measure validity and adoption. So we wanted to build in flexibility to handle different patient-provider attribution models. The slide is to define how we clearly define measures, including the narrative and logical definitions. We supplemented this by detailed technical specifications that outline the exact data elements that were associated with the measure inputs and how these data elements would be summarized to create the measure denominator, numerator, and exclusion criteria. We kept definitions and groupers consistent with registries and clinical decision support within Epic. This allowed us to align our clinical workflows, clinical decision support, and associated performance measurement and feedback and drive improvement. The quality measures data and the attribution models to create a fact table for the patient quality scorecard. This fact table drives quality measures both in Epic as well as Power BI, ensuring that we have consistent and accurate data made available to all the key stakeholders across the organization. So let's shift our focus on specialty care and talk about some of the work that we've done to improve our primary care quality measures for the health system. Similar to our approach in the specialty-based registries, we first identified our clinical quality goals and then identified measures associated with that. We developed EHR-based clinical decision support that would allow us to identify patients with care gaps and would recommend the appropriate action to close these care gaps and allow the provider to document any medical or patient exceptions to meeting this quality measure. We made sure that we provided regular reporting and feedback that would allow our providers and medical directors to identify opportunities for improvement and guide those opportunities for improvement. And we kept this cycle as a continuous quality improvement cycle so that we could keep in touch with changes in best practice guidelines and any updates that would be required for our interventions. For example, the dashboard on the left is the first generation dashboard that was created in SAS. Since then, we've actually moved the dashboard over to Epic and Power BI. Here's an example of how we improve the pneumococcal vaccination rates among our patients 65 years and older. As you can see that, the data is data several years ago. You can see a clear difference in the rate of change in measure performance post-improvement versus pre-improvement. And using our performance improvement methodology, we've not only increased the measure performance, but we've also sustained these results over time. Here's another example of colorectal cancer screening measure. Using measure performance feedback and reporting, combined with EHR clinical decision support and performance improvement methodology, we were able to increase our colorectal cancer screening rates and then sustain these improvements over time. Here's another example of how we used data-driven decision-making to actually drive change in our organization. While we expect that higher wait times are associated with lower patient satisfaction scores, we didn't know what extent it was true at UT Southwestern. To better understand this, we combined insights from Press Ganey patient satisfaction surveys and encounter data from Epic. What we found that patients with longer wait times obviously rated us poorly on our patient satisfaction scores, and they were less likely to return for subsequent visits. Using this data, we were able to guide the medical director and the clinic manager incentive plan and have incorporated this into our operations workflows. In summary, the enterprise data warehouse can be a really powerful tool to bring together data from all these different data sources, allowing us to meaningfully bring together data across the patient dimension. We can gain a comprehensive view of not just an individual patient, but overall patient populations. We can turn data into actionable insights and enable data-driven improvement in patient care processes and outcomes. To date, we've developed a total of 575 performance measures across the health system, and there are 150 measures that are currently in progress. With that, I'll hand over to Dr. Seth Tumay.
Thanks, Deepa. My name is Seth Tumay. I'm the Chief Medical Officer for Ambulatory Operations here at UT Southwestern, and it's really been a privilege to work at an organization that has really spent the greater part of the last 10 to 15 years developing a well-integrated, comprehensive data warehouse, because that work that's been done over the previous decade really enables all the work that we do in all of our missions to be that much easier. And I want to talk a little bit about research and clinical operations and how the curated data really makes those projects easier. So an example from my own practice is, as an interventional radiologist, we encounter patients that have elevated bilirubin levels, oftentimes from a blockage further down in the biliary tree. And so this illustrates that where the blockage can occur, and these blockages are from benign strictures or cancers or other processes. And the question that always comes up in our practice is this patient going to benefit from a drain that gets put in? And so what we do is, using a variety of techniques, we can advance a needle into these dilated biliary ducts and put a drain in to decrease the bilirubin level. Obviously, the procedure is invasive and risky and carries potential negative consequences. So patients and patients' families don't want to undergo the procedure unless we can provide them with some reasonable evaluation of if the bilirubin is going to decrease. So to evaluate that transition from post-drain decrease in bilirubin, it was pretty straightforward to request the last 10 years of data from the data warehouse and look at all of the labs that may go into predicting whether a patient's going to benefit from having a percutaneous biliary drain. We're also able to look at other medications that were administered concurrently, such as chemotherapy regimens in different cycles, and come up with a really good predictive model of whether patients are going to benefit from a biliary drain. And this is just one example that of a way that getting data out of the data warehouse really makes performing research on our patient populations a lot easier than if we had to spend the time pulling these data elements individually. So that's one example. So on the operational side, same advantages really come shining through in that for each strategic initiative for the ambulatory practice, we have developed Power BI dashboards to inform how our different business units are operating. And so this particular Power BI dashboard was generated to track new patient visits into the ambulatory practice, and as you can see, you can slice and dice by departments, divisions, and really down to the clinic level and physician level to identify really how our interventions are affecting the patient flow into our operations. Similarly, you can have advanced visualizations of physician-level performance of workflows in the clinic. And so this is an example of another way the data can be put to use. Also, we have the ability to run some advanced visualization tools in our Power BI environment. It's really handy to inform physicians that their change in behavior really does make a difference. And in this graphic, blue is good and represents a positive change in workflow. Another way that we leverage our rich data warehouse is to evaluate the performance of our transplant patient population, particularly in the solid organ area. And so all of the transplants that are performed and their outcomes are tracked in the data warehouse, and it really enables UNOS reporting and really allows our clinicians to have a good understanding of what's going on in our transplant populations. Specifically, we can look at all sorts of survival, length of stays, and other quality measures around the different transplant populations over time. Survival curves over time as well, and again, these types of survival curves let us know that there is a survival benefit relative to expected for having the transplants done at our organization. Again, different survival curves can be sliced and diced based on time and who performed the procedure and different criteria from the donor graft. It's just really been a pleasure to work and practice medicine here at UT Southwestern because, again, the data that's been curated over the last 10 years really does enable and enables getting high-quality data out and really lets us get actionable measures so we can see improved outcomes for our patients. And that's all. Thank you.
Well, thank you for the presentation, and a great presentation. And I want to remind folks where to go find other Davies use case webinar along with this. The use case webinar and information on how to apply for Davies Award can be found posted at the HIMSS Davies Award website at hims.org/Davies. So thanks again.